Right, hello everyone. Welcome to to Materials Engineering Program presentation. Let me introduce you to what Materials Engineering Program is about. And I'm going to start by discussing a little bit what material engineering itself is about. And I'm gonna start by making a simple point that, well, everything is made from materials, right? You cannot make anything without materials. So therefore, you would like to understand how materials behave while they are being made into something, and how different objects we experience, how they serve their purpose, depending on from which materials and how they are made. Seems like an obvious statement, right? So whether we're discussing like a bridge, a major civil sort of civil structure, or a phone, or a battery, or an aircraft engine, everything depends on the materials it is made from. If you look through the history of the civilization, from the Bronze Age to modern society, every major step forward was driven by the development of a new material. Materials pretty much shape what technology can do. When a new material becomes possible, a new class of products becomes possible. So as materials engineers, we work with metals, ceramics, polymers, composite materials. You might have heard these terms before. So each material, steel, aluminum, polyethylene, titanium, a complex combination of those, each behaves differently, right? Well, if you think about like glass and steel, like sort of an obvious experiential distinction as well. Glass can shatter, and steel is very difficult to deform, right? It takes much more effort to shape a steel component into something. Some materials, they conduct heat and electricity better than the others. Some materials are insulators. You know that wiring has plastic insulation, right? So the reason why different materials behave the way they behave comes from what those materials intrinsically are in their structure, from atoms and molecules all the way up to the microstructure of the materials, which is formed during the manufacturing. The way the material is processed or made into a part defines the material structure, which further controls the properties that we experience as users of the products. So materials engineering, broadly speaking, focuses on understanding that connection between manufacturing conditions, processing, the structure that develops inside the material, and the performance characteristics of the materials. As materials engineers, we study why materials behave the way they do, how to choose the right materials for an application, and how to design or discover new materials. And equally important, we look at better ways of manufacturing materials, how to make sure that they perform reliably, so they don't break too soon, so they serve in a safe manner, right? So the cars we drive do not rust too soon, that type of thing. So in short, materials engineering is about analyzing materials, improving them, creating new ones, and enabling technologies that depend on them. Now, what can you expect from the curriculum in this degree? So it's a 4-year program. Our department is a smaller department by size, which is very typical. All materials engineering programs across the world are sort of exclusive community, right? Every year we admit about 50-60 students into the program. There are benefits of being in a smaller program. This gives you more access to the instructor's time. This allows you to build a more engaged relation with the material through the instructor, right? In terms of hands-on experience in the program, we have several classes which take you through different testing procedures and protocols. You look into different manufacturing techniques and such. If you wish, from early on, you can start approaching the faculty who do research, and you may show interest in joining their labs. That is highly encouraged. Second year of the curriculum is dedicated to learning fundamentals, mostly. That is, understanding thermodynamics, physics, math. These fundamental concepts are necessary to start looking into more applied and engineering-oriented questions and disciplines starting from year 3. So in the 3rd year, in term 1, sort of the focus is on the materials processing. So when a material is manufactured into a part, it has to experience some physical changes to its state. Simply put, most often you need to hit the material up, sometimes to make it softer, sometimes to make it liquid so it can run and be, for example, poured into a mold and later on cool down and solidify. And through this process, the physical states and physical behaviors of the material, they need to be measured, quantified, understood, such that manufacturing process can be designed efficiently, right? So someone could analyze how much energy is needed to input into the process such that quality product can be made. In term 2 of the 3rd year, you start looking at different types or different classes of engineering materials, such as ceramics, metals, polymers, and their composites, as well as taking like a deeper dive into structural properties of the materials. So there is this lab class which teaches you formal protocols for characterizing materials. In the 4th year, you can choose a specialization, right? So there are 4 available streams for you to consider. Materials manufacturing and performance. That would be the first one. Second one is the aerospace materials stream. Third one is biomaterials engineering, and the 4th one is minerals and metals extraction. So those streams, as those names suggest, they look either at different application areas, perhaps well, let's for instance look at this materials manufacturing and performance stream. So the point of this stream is to introduce you to this big picture type understanding of how materials generically behave when undergo the manufacturing process. So what I said before about materials being, heated up, experience transformations along the way when being shaped, all that sort of works differently when different materials are applied in different manufacturing processes. So materials manufacturing and performance stream is this deeper dive into the variety of combinations of processes and their materials. In the aerospace materials stream, we would spend time discussing, well, what are the materials actually used in, aerospace applications? So why aluminum, titanium, and sort of fiber-reinforced polymers are the materials of choosing? Why fatigue and fracture behavior are so important? What are the high temperature materials available for aerospace applications, and what makes them special? How do you characterize the properties that are needed to design durable and strong and safe aerospace structure? So those types of things. In biomaterials engineering stream, well, we can say the question would be, well, which materials can be safely put in contact with biotissues, right? So biomaterials engineering stream is, largely about which materials should be used as implants. What are the considerations for the materials to be used for implants? Clearly, it's a very important subject. It's a very humane subject. For minerals and metal extractions stream, the focus is on how obtaining materials from ores actually works, and what is the impact of extraction techniques on material chemistry. So those need to be considered such that metals extraction can be done in this sort of ethical and sustainable fashion without causing much harm to nature. Exercising responsibility is one of the principles by which engineering practice needs to be done. So, what can I expect from my student experience? Outside of the curriculum, there is a number, it's a great number of student clubs that you may join. Our students are very active in Formula. It's the racing car. UBC Vulcan is a club which is focused on pretty much forging, interestingly. We have students in our department who pretty much run what is called UBC Waste Nuts. It's a sustainability recycling team, pretty much. And there are really more. I'm pretty sure that our students can be found in all the teams. Solar panels, well, you name it, pretty much. Our students have a good history of getting to the leadership roles. Traditionally, we're very proud of our students for assuming the leadership roles, and in here we can see just a few of them. So, like we mentioned before, undergraduate research assistantship is pretty common for those who are interested. That is, if some students are interested or are thinking of grad school, for example, or if they're trying to decide if research and development as a job is something that may work for them, then early on, starting from the second year, you pay attention to what your instructors are telling you, and you may approach your professors, those who run research labs, and you express your interest in the field. And if things work out well, you can get like a summer internship to work in the lab to see if that resonates with you, if it aligns with your interests, right? Quite many of our students are engaged with the co-op program. It is a very valuable experience to go onto those internships, to experience professional working environment outside the student desk before you graduate. So whole program is available and very much encouraged. What is the demand for materials engineers? In short, there is a great demand for materials engineers in North American industrial environment. A well-trained materials engineer will always find a good job. In here, one of my colleagues sort of summarized some statistics from the employment of our past 180 alumni. You're welcome to sort of look at this chart. You can see that all sorts of industries are hiring materials engineering students. So you study well, you make efforts to develop a well-rounded portfolio, and you will have choices. Good to remember. So what career options can I pursue for my degree? So essentially, this is a quick board summarizing the logos of different companies across different industries. Here you can have on the bottom right, there are some aerospace companies like Boeing, Apple, SpaceX, automotive sector, energy sector, failure analysis, material testing industry. On the very left, these are extraction processing type companies. So whatever you may think of. So at this stage, how about I'm gonna finish the formal part of the presentation, and I would be happy to take any question that you have. You're welcome to use the chat or Q&A. Well, all right then. Thank you for joining this session. Have a good evening and bye-bye.